Hello students, welcome back to the class. For the third sem, as you are having the current electricity chapter, so in that chapter we are moving to the next subtopic of the chapter, that is nothing but the transient circuit. Okay, so in the transient circuit, the first point I am going to derive is the growth of the current in a circuit containing resistance and inductance which are connected in series with each other. Means when the current increases in a circuit, what are the changes happens there? So that we are going to find, that we are going to derive. So here as we are taking for this the resistance and the inductance, this is the resistance and this is the inductance which are connected in series. So both are connected in series. Again this combination is connected to the battery in series. Then we are having the plug key. So for the study of the growth of a current in a circuit containing resistance and inductance which are connected in series, we want one resistor, one inductor, one battery and another one is a plug key. So all are connected in series with each other. So for this series combination, as if you move about the electrical instruments, the first one is the resistance. So already you know the resistor means what? This is the resistor. So resistor is the electrical instrument which opposes the flow of the current. It just opposes the flow of the current. So as it is inversely proportional to what? Current. And the inductor is also an electrical instrument. Actually it also opposes the current, but it opposes the change of the current. It is opposing the flow of the current. It is opposing the change of the current. Change of the current means what? The current may increase or the current may decrease, isn't it? So whenever in the circuit, if current goes on increases, then it will oppose. If the current goes on decreases, then also it will oppose, isn't it? If the current will be constant, then there will not be opposition from the what? Inductance. That's what the thing. So now I hope you understood well about the resistor and the inductor. Resistor is an instrument which opposes the flow of the current. Inductor opposes the change of the current. So as you know, battery will give the what? EMF, and this is the plug key to start and to off the electrical circuit. So let's go into the thing. Now when current flowing in a resistor, so it is opposing the flow of the current. That time the voltage across these two ends, across the resistor, the voltage will be given by, I will write it as Phi1. The voltage across the resistor is nothing but Phi1 I will write, which is equal to current into resistance, isn't it? I into R according to the what? Ohm's law. So we know Phi is equal to I into R. So in the same way, when current is flowing in a resistor, the voltage across or the potential difference across these two ends is nothing but what? Phi1 is equal to I into R. Next, again that current will be flowing in a what? Inductor also. So when it is flowing, means it may increase or it may decrease. That time the inductor also produces what? The electromotive force, isn't it? So it is producing the electromotive force, because as we studied, whenever a current is flowing in a conductor, it produces a magnetic field in a surrounding area, isn't it? So when it is producing the magnetic field, it depends upon the current strength. When current changes, the producing magnetic field also what? Changes. If current increases, magnetic field producing by a conductor also increases. If the current decreases, then the magnetic field produced by a conductor also what? Decreases. So as this is the case, that time there will be production of what? Electromotive force in this. That time the between these two ends, that electromotive force is given by Phi2 is equal to L into di divided by dt. So L is nothing but inductance we will call. So nothing but self-inductance you can say, isn't it? So L is the what? Self-inductance. So we got Phi1 is equal to I into R and Phi2 is equal to L into di divided by what? Dt. Now as the battery supplying the voltage, you already studied when instruments, electrical instruments are connected in series, that time the total voltage will be distributed among these two, isn't it? But the current will be what? Same. See, when we will start the key, this one, when we will plug the key, that time the current starts to flow, isn't it? So let it be the current flowing at a time t. I will take it as I. So I current will be flowing in this. So when current will be flowing, if they are connected in series, same current will be flowing in R as well as in L. That's what I and I current is flowing. But whatever the potential difference or the voltage supplied by the battery is there, it is distributed among these two. So it will be what? Distributed, and that is what? Suppose the total voltage, let it be E I will take. It is giving the voltage, means EMF we can say. So that is E, means how much it will be distributed? Phi1 in R and Phi2 in what? L, isn't it? So that's what we will write the equation. The total EMF is equal to Phi1 plus Phi2, isn't it? As it is distributed, suppose 6 voltage it is supplying, then 3 voltage will go here, 3 voltage will go here, like that, isn't it? So E is equal to what we got? Phi1 plus Phi2. As we know the Phi1 and Phi2 value, we will substitute here. So what we will get? We are getting E is equal to Phi1 value is I into R plus Phi2 value is L into di divided by dt. So this is the first equation. The EMF supplied by the battery is something will go to resistor and something will go to inductor, which is equal to I into R plus L into di by dt. Now we will solve this equation. See, just go on, imagine the thing. When we will press this key, the current starts to flow, isn't it? So before pressing, means when time is equal to 0, then what will be the current in the circuit? There will not be any current in the circuit. Are you agree? So whenever before pressing the key, you can say, means at time t is equal to 0 we can take. That time there will not be current in the circuit. That's what I is equal to 0 we will take. But after that time the current suddenly will not increase to the maximum value. So let it be, it will be randomly increasing in the what? Circuit. At time is equal to t second, the current in the circuit is I we will take. So how much current will be there? That is equal to I. Then after a certain time, after a certain time it reaches to the what? Maximum value, and that maximum value current we will take it as I naught, isn't it? See, starting the current is 0, and as current time will be passing, the current goes on increases and increases. At time t is equal to t second, the current in the circuit is I, but after a certain time it reaches to a maximum value. So that time the current will be what? I naught. This is the maximum current in the electric circuit. This is the current when time is equal to 0, and current will be 0 when time is equal to 0 second, isn't it? And now coming to the point, when current increases to a maximum value, means when I is equal to I we can take. When I is equal to I, that time what will be the inductance in the what? Inductor. L is equal to what we are taking. See, once current reaches to a maximum value, here the self inductance becomes what? 0, because when it is opposing the change of the current, isn't it? But it will not oppose the what? Same current, constant current. That's what, when it is reaching to the maximum value I naught, then the inductance produced by a inductor will be what? 0, because it will not oppose the constant current. Only the change of current it will oppose. So L into di by dt is equal to 0. Okay. So this value we will substitute in the what? First equation. What values? I is equal to I naught and L into di by dt is equal to 0. So now the equation becomes what? E is equal to I becomes what? I naught. So I naught into R plus L into di by dt value becomes what? I is equal to I naught. If it is, then it will be 0. So plus 0 we got. So that is what? E is equal to I naught into R. We got the equation. Now substitute this equation again in the equation 1. Means what value? E is equal to I naught into R. This value you substitute in the first equation. So what is the E value? I naught into R. So substituting in the first equation, substitute this value in equation number 1. So in equation number 1 we are substituting. Then what we will get? We will get E value as I naught into R. So we are getting I naught into R is equal to I into R plus L into di by dt. We got the equation, isn't it? Now we will solve this one. So I into R I will take to this side. So it will become negative. So I naught into R minus I into R is equal to L into di divided by dt. We got the equation, just transferring. Then what is the common term out of these two? So R will be common, so take outside. What will be remaining? I naught minus I will be remaining if you take R common. Okay, so this is equal to L into di divided by dt. Now what I will do? I will make I terms one side and other terms another side, isn't it? So what are the I terms? One is I naught, means current terms, I naught, I and di. So make in one side. So what we will get? Transfer I naught in minus I to this side. So is it divided here? So what we will get? We are getting di divided by I naught my I. Then this one we transferred this side. So now what are the terms remaining here? One is L and one is dt. So transferring these two terms this side. So what we will get is equal to R will be there only and value L will go. It will be divided, and as dt is divided, after going here it will be multiplied, isn't it? So we are making current terms one side and other common terms in another side. So if you make, you are getting this value. Now to solve this, I am integrating. The above equation. So integrating on both the sides. So when we will integrate on both the sides, so what we will get? We are getting integration marker, that is integration of di divided by I naught minus I is equal to integration of R by L into dt, isn't it? So this one is integrating with respect to I and this one is integrating with respect to time, that is dt. So as we know, 1 divided by x, integration is log x. So in the same way, 1 divided by I naught minus I will be what? With respect to I, the integration log of I naught minus I, isn't it? But as a minus I is there here, so what we will get again by the chain rule? Minus 1 will be there, isn't it? The integration of this di divided by I naught minus I, it is like 1 by x into dx integration, dx by x. So dx by x integration is log x. So in the same way, this integration will be log. But as two terms are there here, I naught minus I, with respect to I we are integrating, that's why minus I, again integration will be what? Minus 1 we are getting divided. So this is equal to R by L is a constant quantity, resistance and inductance, into integration of dt. So what is the integration of dt? Yeah, it will be t and plus 1 constant will be there for the integration. Constant term will be there. Now, so this is, we can write like this. Is it will be minus? Because divided by minus 1 is there. So minus log of I naught minus I is equal to R by L into t plus k we are having, isn't it? And now I want to find this constant term value, that is k value I want to find. So what I will do? I will substitute when t is equal to 0, means when time will be 0. So as already I said, when time will be 0, what will be the current in the circuit? It is 0. So when time is equal to 0, I is equal to 0. Come. So now substitute these two values, t0 and I0. So this equation becomes what? This will be minus log I naught, because I become 0, which is equal to, this whole term becomes 0, which is equal to k, because t is 0 here and I will be 0. So we are getting minus log I naught is equal to what? K. Now we got the k value. What is the k value? K value is minus log I naught. So substituting in the this is, I will write it as second equation. So substitute in the second equation, what we will get? We will get the new equation, that is minus log I naught minus I is equal to R by L into T, and plus minus it will be, because K value is minus log I naught. So K value substituting minus log of I naught. We got the equation. Okay. So now it is easy to solve the equation. So I will make two parts here. Same equation I will write here. So what equation you got? This is minus log I naught minus I is equal to R by L into T minus of log I naught, just substituting the K value. So we got this equation. Now solve this equation. So solving, what we will get? We are getting now this term I will transfer this side to make positive, and this term will be this side. So what we will get when it will go here? It will be plus, is it? So log of I naught minus I, and it will be there only. So minus of log I naught, which is equal to, as it is coming this side, it becomes minus, isn't it? So minus R by L into T. Is it the equation we got? Now, as you know, log U minus log V, we can write like a log U divided by V. So in the same way, I will write this one. So writing, what we will get? We are getting log of I naught minus I whole divided by I naught, like a log U divided by V, which is equal to minus R by L into T. Thing you got. Now log, when we will transfer, no, it become e raised to we will get. So this value becomes what? I naught divided by I naught minus I divided by I naught, isn't it? I made separate for those two. So which is equal to log we are transferring, so it becomes e raised to minus R by L into T value we got. Now solving this, I naught minus I becomes what? 1 minus I by I naught is equal to e raised to minus R by L into T value we got. Now in terms of I want to see, so that's what. Now this term I will take this side, and this term I am taking this side, so it will become positive if it is goes. So what we will get? I by I naught is equal to 1 will be there only, and this is going to this side, so it becomes minus R by L into T we got. Now I is equal to what then? So I is equal to I naught will go here into the bracket, it will be there, this term will be there, that is 1 minus e raised to minus R by L into T, isn't it? So this is the current value we got. So current value is equal to I naught into bracket 1 minus e raised to minus R by L into T. Now one substitution I will make here, that is put T is equal to L by R. So we are taking time value as equal to how much? L divided by R, that is inductance and resistance. So if you make like this, what will be this value? So we are getting E is equal to I naught into the bracket 1 minus e raised to. So when T is equal to L by R, so when it is L by R, L get cancelled, R get cancelled. So what you will get? E raised to minus 1 we are getting, isn't it? Now solve this one. So what we will get? I is equal to I naught into the bracket 1 minus, so e raised to minus 1, when it will go to the denominator, it becomes what? E raised to plus 1. So 1 divided by e would have got. So which is equal to I naught into the bracket 1 minus 1 divided by, as we know the e value, I will solve this one. So we know the e value, which is equal to 2.72, isn't it? So 2.72 value we got. So that's what I is equal to. So if you make this calculation, that is 1 minus 1 divided by 2.72, you are getting approximately 0.632. So you do by doing the calculation this one, okay? So you are getting 0.632. What is remaining? I naught, isn't it? So we got I is equal to 0.632 into I naught, isn't it? And this is called as the current value. So what will be the current? Increasing. So this is the maximum current in the circuit. So current is equal to 0.632 into the maximum current. When we are getting 1 T is equal to L by R. So this T is called as, that T we are calling it as what? Time constant, isn't it? So at the time of this one, the current will be this much, isn't it? So that is what we called it as a time constant. So in examination for 2 marks, they will ask the definition of the time constant. So time constant is the current which is 0.632 of maximum current reached by the circuit. So time constant is defined as the current in which the current will be something when 0.632 of maximum current reached by the what? Circuit. That is called as what? Time constant. Okay. So for examination, they may ask, explain the growth of current containing resistance and inductance. So when they will ask, you should explain like, so for this we are having resistor, inductor, battery and plug key, and all are connected in what? Series. Means the resistor and inductor are connected in what? Series. When we will press the key K, that time when time is equal to 0, there is no current in the circuit. But as the time increases, the current goes on increases and increases, and at one point it will be what? Maximum. That is what? I naught. So I naught is the maximum current. Now resistance is the opposition to the flow of current. Inductance is the opposition to the what? Change of the current. So that's what, when battery supplying the voltage which is equal to E, it will be distributed among these two, that is V1 and V2. So when we will write the equation, that is E is equal to V1 plus V2, and V1 is the potential difference across the resistor which is equal to I into R, and V2 value is what? L into di by dt, where L is the what? Inductance. L is the inductance. That inductance is nothing but what? When current is flowing in the conductor, it is if current changes, then it is producing the what? Magnetic field. So due to that, the electromotive force had been created, and that is called as what? Inductance. That is L value. So that is equal to L into di by dt. Now as we saw, when current becomes constant, that time it will not oppose the flow change of the current. When current becomes constant, then there is no opposition from the inductor. So L into di by dt is equal to 0 we got. So substituting these values in equation 1, we got E value is equal to I naught into R. So again substituting this E value, that is I naught into R, again in the equation number 1, we got the equation. So simplifying the equation, mean transfer IR to this side, so it becomes minus IR, take R common, so I naught minus I into R is equal to L into di by dt as it is, and make I term one side and other terms another side. So we got di divided by I naught minus I is equal to R by L into dt. Now to simplify this, we are integrating on both the sides, so integration we taken. Now as we know, dx by x integration is log x, so in the same way di by I naught minus I integration will be what? Log of I naught minus I divided by minus 1, because two terms are there. So which is equal to R by L into T plus K, where K is the integration constant. So now our task is to find this K value. To find that, what we substituted, we put T is equal to 0, means when time is 0, there is no current, so I is equal to 0. So substituting here, we got K value as minus log I naught. Again substituting in the equation number 2, we got this equation. Okay, so minus log of I naught minus I is equal to R by L into T minus log of I naught. So to make a positive, we transferred here and this term here, so it become positive, and when it will come, it will be negative. So it is like log u minus log v. So log u divided by v we got, which is equal to minus R by L into T. Now log we transferred this side, so this become e raised to we got, and simplifying this separately, we got I naught by I naught minus I by I naught. So which is equal to 1 minus I naught get cancelled. So 1 minus I by I naught is equal to e raised to minus R by L into T we got. and 1 you transfer, means this term transfer this side and minus I by I naught term this side. So again it positive and it becomes negative. So transferring I naught, we will get multiplying term here. So that is I is equal to V got. And when we are substituting T is equal to L by R, what is T? T is the time constant. So I is equal to I naught into the bracket 1 minus e raised to L get cancel, R get cancel. So we are getting e raised to minus 1. So that's what the thing is. I is equal to I naught into the bracket 1 minus, as it is coming to the denominator, it becomes positive 1 divided by e. So which is the value having 2.72. So just if you solve this one, we are getting how much value? 0.632. So I is equal to, finally we got 0.632 into I naught. In terms of percentage, if you want to say, it will be how much? It is 63.2 percentage, isn't it? See, suppose 100% current, 100 ampere of current is flowing, means to reach 63.2 ampere of current of the maximum value, that is called what? The current, that is the time constant. Okay, so time constant is the current in which is 0.632 of maximum current reached by the what? Circuit. So that's what the thing. So I hope you understood all the mathematical stuff and also the concept. So just by seeing the video, you go on writing the notes. This is just the derivation, is the simple derivation. So by seeing the video only, you go on writing the what? Notes. Okay. Thank you.